Hi, today we are going to introduce our new engine hardware generation to you, which is Evo 3 Pro. And let's look under the hood. This is the third generation of our engine hardware. This is Evo 3, and this is the Pro Edition, which is utilizing the RTX 6000 Pro GPU, the 600 watts version. When designing every generation of the hardware, we have four important criteria. And those are first the GPU, then the CPU, and then the power delivery to especially the GPU. It's power hungry. And the thermal management inside the chassis for all of these components run under stress during live productions. The successful combination of these four elements define the performance of our engine hardware. Let's dive into the details of those four elements.
Starting with the GPU. The GPU, this is RTX 6000 Pro 600 watts edition.
Yeah, the GPU is the most critical part for our use case. When choosing the components, we always pick the best available GPU in the market in every generation that money can buy. And here it is the 6000 Pro 600 watts edition. This is the Blackwell Series GPU, and it's delivering the best available graphics rendering performance for Unreal Engine 5 and for our Reality 5 solution at the same time. And also the CPU is from AMD. It's the newer version of the AMD.
That's the Ryzen 9 9950X3D.
In the previous generation, the Evo 2, we had one version older of this CPU.
We had 7950X3D, and now we have the latest one, 9950X3D.
Yeah, the reason why we are choosing these CPUs, it may be even the best gaming CPU in the market. It's delivering extremely good single-threaded performance, and for Unreal Engine game thread, this is quite important. That's why we are going with the gaming CPUs, because it's much better than going with a lot of cores and slower single-threaded clock speeds. These CPUs are helping with the game thread of Unreal, especially with complex scenes with many actors, let's say too many blueprint scripts. When things get complicated, you need a lot of CPU power, which must be a single-threaded game thread of Unreal Engine 5. It must be running as fast as you can. And this is where the gaming CPUs shine.
And also the huge 3D Vcache performs much better in Unreal Engine workloads.
The power delivery is one of the most critical subjects in our Evo series. The most important one is the power delivery to the GPU. And usually when you get a Quadro GPU, the new names are Workstation Series, I guess, those GPUs come with something like this. PCIe power, 8-pin, 4 inputs. You have to connect 4 cables inside the chassis and then plug this 12-volt high-power connector to the GPU. And if you have room left, you can maybe close the chassis. This is how you deliver power. And this is really, really important, because if things go wrong, this cable, these connectors may melt, and it may kill your GPU. And we don't want this, definitely, while we are on air. This is how we designed it. It's actually, we designed a special PCB which goes to the 45-degree angle power connector of the 6000 Pro GPU. And actually, we are just delivering an XT90 2-wire power cable, which is carrying around 50 amps under full load at 12 volts. It's huge power, 600 watts, and delivered with this 2 wires only. This helps us to have a lot less cable clutter in the chassis while ensuring the connection of these 12-volt high power connectors, because when we screw this component to the GPU, when we tighten the screws here, we are also applying a gentle pressure to the connector all the time so that it doesn't move from where it needs to be.
And also this 3D printed part helps us securely placing the GPU because it's quite heavy actually, and there are lots of incidents with the breaking of the either motherboard or GPU.
The PCIe slot, right?
Yes.
It's a very important point because these GPUs weigh almost 2 kilograms each. And if you don't really secure this good enough in the chassis, and when you move the computer with the GPU inside, all that pressure is going to break the motherboard slot or the PCIe connector of the card. There are many incidents like that, and that's why we are trying to make all the parts rugged and the chassis rugged, and even protecting the chassis from flexing with this strut bar here. This is also another important point.
In order to get the highest performance with our GPUs, both in the volume and with the power requirements, you cannot find easily any common off-the-shelf hardware to house these large GPUs. So we had to design our own.
So in order to drive the chassis, we have designed our own PCB and put our microcontroller. This is connected to the motherboard as well as the power supply, so it knows what kind of power the chassis is consuming. Rather than just reading the temperature of the CPU and GPU and read some temperature sensors and increase the fan speeds accordingly, we are not doing that. We are reading the power supplies output, and if the power usage increases, we directly increase, without waiting, the speed of the fans. If you consume a lot of power, then it's going to end up with heat inside the chassis. So why wait for that? We know the power usage increases, and without heating up the components, we increase the speed of the fans. This is quite effective to keep the high performance of the CPU and GPU working all the time without dropping frames. So if you can keep these components like the CPU and GPU lower than these thresholds all the time, you will get consistent performance. This is why we are proactively cooling it before it gets hot. The CPU has 2 fans here, and they're blowing through the cooler of the card. So actually, if we didn't have this part here, the hot air would go into the CPU intake, into the power supplies cooling intake, into the memories, into the motherboard, everywhere. So we need to isolate that and take it out to the exhaust without getting it back again into the intake. This is serious. This is 600 watts into the chassis. This huge amount of heat that should be isolated as fast as possible. Let's have a look to the ports of the computer. We just have the required port for our production. We have a track network port, we have a house network port, and we can have up to 2 STI I/O boards in the chassis. This is the primary slot. This one is an AJAC Corvid card.